Okay, welcome to the second half of the video for Notes 4.2 and Math 31. And picking up a little bit where we left off, we're going to be doing some factoring to help simplify fractions. But the first thing is to get you to understand that fractions can be written in any number of ways. The same fraction might have millions of ways of writing it. Bobby isn't the smartest person in the room. That's putting it politely. She wants to go on a diet and she decides to cut back on the half pizza she eats for lunch every day. So here's her half pizza that she eats. And this is a square pizza, but there's the whole pizza. So, judging that a thinner slice will have fewer calories, she's actually right about that. She decides to cut the pizza into smaller pieces. So let me cut this into 12 pieces. And then she proceeds to eat 6 of those 12 slices. Well, you can see she's eating the same amount of pizza. So she is eating smaller pieces, but she's eating more of them. And that exactly compensates for the smaller size of the piece. So what we have here is a case where 1/2 of a pizza is exactly equal to 6/12. And you've heard the saying, half of one, um, half dozen of one, and 6 of the other. Well, that kind of comes from this problem here, okay? 6/12 and 1/2 are numerically the same value. Now, if she wanted to take that to an extreme, she could cut this pizza into 40 little thin, tiny slices. I don't know if I can do this here, but picture 40 of those slices. So 1, 2, 3, 4, there'd be a bunch of them here, okay? I don't think I've got the right number there. But if she had 40 slices and she ate 20 of those 40 slices, well, she's back to eating a half of a pizza. So 20 out of 40 is also half. Okay, another way to illustrate this might be to think of this as portions of your wealth. A person with $2 who gives away $1 is giving away half their wealth, while a person with $12 is going to give away $6 if they give away half of their wealth. And if you have $40 in your wallet and you give $20 to somebody, you also give away half of your wealth. Okay, so now we're going to go the other way, and this reversing of this process is called simplifying. So when we get the numbers to go down to their smallest possible choice, 1/2 in this case, that's called simplifying. All right, so here's how you're going to simplify this. You're going to take 6/12, and you're going to write it with the biggest factor that is common to the top and the bottom. These are both multiples of 6. And then you're going to write it as 6/6 times 1/2. We're going to do this much faster in a minute. And 6/6 is 1, so we have 1 times a half, and 1 times a half is just a half. So let me show you all of the parts that can be crossed off. Multiplying by 1 can be ignored. So here's the multiplying, and there's the 1. Here's the multiplying, and here's the 1. So we're going to cross all of those off. Multiplying by 1 makes no difference. And you can see that we end up with 1/2. Now, in the process, there's a much faster way to do this. You determine the biggest number that goes into both of them, in this case 6, and you should do this in your head or verbally. You're going to divide each of these by 6. Divide this one by 6 and divide this one by 6, and you've got your answer. Okay, so we're going to do the same thing down here. These numbers are both divisible by 5. So let me make it larger before I work on it. I'll divide this one by 5 and this one by 5. And so 30 over 35 is 6/7. Now I actually like to show the division so that you know what I'm dividing by. So this is how I sometimes show it. These both divide by 6. So you get 3 over 4 here. Now somebody might notice that they also divide by 2, or you might notice they divide by 3. Well, if you think about it, 2 times 3 gives 6. You want the biggest number that you can do it with. Okay, the biggest number that divides into 72 and 60 is 12. And that gives 6 over 5. Improper. And you'll notice this was bigger than the one below it anyways. We knew it was improper at the start. Okay, putting that x next to it doesn't really change how you do this part of the problem here. You're just going to simplify the number part of this here. So you divide this by 7 and this one by 7. And when you divide them by 7, you get 6x and 8 on the bottom. All right, the x just kind of stays out of the fight there, and you just simplify the numerical part. Now there are problems later where we actually can work on the back half that has variables. We'll come to those in a minute here. Okay, 72 over 60. You can, I mentioned you can divide these both by 12, but if you didn't see that, you can take this in stages. Let's say that you notice these are both divisible by 6. That would take you to 12 over 10. Well, then you just take it and divide it by 2, and you end up with your 6/5. That's one way to get that done. Here's another way to get it done. Let's say you notice this is divisible by 2. That would take you to 36 over 30. And then you look at that and go, oh, I can divide both of those numbers by 3. So we'll divide them by 3 here. And that takes you down to 12 over 10. And then dividing by 2 will finish the job here. It's slower, but you have the advantage of being able to use any of the numbers that you recognize that go into the problem. Of course, the easiest way here is the way we did on the other page, 72 over 60 divided by 12. And that larger number just gets the job done in a hurry. So the moral of that story is the bigger numbers will get you to the answer quicker, but the smaller numbers, sometimes if you take it in nibbles, you can get there more safely. All right, if you write the numerators and the denominators with their prime factorization, here's where that comes in, then you can just cross off the common factors. So let's do 72, break it up into, let's see, I know that's 12 times 6, and this would be 2 times 6. There's a prime number. This is 2 times 3. Those are both prime numbers. And the 6 breaks down into 2 times 3, and those are prime numbers. So the 72 is, I think we have 3 2s, yep, and 2 3s. Oops. And then the 60, we'll break that up. Let's see how that breaks up. 60 is 5 times 12. And that would be 2 times 6. Let me circle the prime numbers so far. And 6 breaks them into 2 times 3. And one of the things I don't like about the tree method is you can easily lose something. But anyway, you get 2 times 2 times 3 times 5. Now, once you've gone to all that work, you can cross off the common factors. These 2's cancel, these 2's cancel, one of the 3's cancel, and you can see that across the top I have 6, and across the bottom, 5ths. So we get the answer yet a different way when we did it that. So let me give you one more example of this. If you were to find the prime factorization of 40, it'd be 2 times 2 times 2 times 5. Let me convince you that that's correct. 2 times 2 is 4, 4 times 2 is 8, 8 times 5 is 40. And you could use the tree or the line and primes method. Okay, the 56 is going to get this one here. And again, you could do the tree method on that if you wanted. But now that you got all the prime factorization done, you can cross off the ones that divide into 1. 2 over 2 is 1, 2 over 2 is 1, and 2 over 2 is 1. Your final answer here is simply 5/7. So the simplest form of 40 over 56 is 5/7. Okay, when you have variables, if they're matching on top and matching on the bottom, this next example has ends on both places, then you're just going to write them all out as a multiplication instead of the exponent. So if you do the work for 30, you're going to get, let's see, 30 and 42 both divide by 6. So I'm going to say 6 times, it's not a prime number there, but 6 times 5. And the other one's 6 times 7. And then we'll extend it here. The top has an n times an n times an n. And the bottom has 1, 2, 3, 4, 5 of them all multiplied together. So we'll cross off this one. We'll cross off these ones. And we end up with leftovers. 5 on top and 7n squared on bottom. Okay, the next one, number 12, if you write it out, 7 and 21 both divide by 7. So I'm going to write it as 7 times n. And down here, 7 times 3. And then there's 4 n's here. Cross off the common factors. And we get 3 to the 3n to the third power on the bottom. Now the top appears to be blank, but you never leave it blank. 7 divided by 7 is 1, so this is actually a 1 here. And n divided by n is also 1, so we have 1 times 1 across the top. So if everything cancels, you're going to put a 1. 1 over 3n to the third power is the answer to that one. Okay, the next thing we're going to look at is how do you know if fractions are equal? Well, you're going to simply simplify both of them, and if you get the same result, you say, oh yeah, these are the same fraction. It's one of the reasons why we simplify is to compare them. So we get 3/4 for that one. And if I take 21 over 28 and divide by 7, you can see that this would also be 3/4. And so, yes, 6/8 does equal 28. Okay, now let's do the same process with the next one, 16 over 24. When you simplify that one, we can divide these by 8. You get 2/3. And if you try the same thing with 8/12, these divide by 4, you get 2/3. And so, yes, these are equal. Okay, there is another way to do that, and I'll show it to you. If you set it up as a proportion, and a proportion is a fancy name for two equal fractions. If you set it up 1 over 2 equal to 7/14, and if this is true, then they really are equal. Your cross products should be the same. So you're going to multiply those two numbers. Product means times. And in this case, you get 14. And then you take the other cross product, 2 times 7, and that also gives 14. If those are equal, then the original is also equal. So you're looking at the cross products and comparing them. So is 8/9, here's another example, equal to 5/6? Well, in the downhill direction, you get 48. In the uphill direction, you get a different value, 45. And since those aren't equal, the original fractions are not equal. And ladies and gentlemen, that does it for section 4.2. I hope it's a clear enough presentation that you understand what I've been trying to get across here. Thank you for sticking with me this long.